Today, we're diving into some truly groundbreaking research about a rare and devastating disease. But what scientists uncovered might just hold one of the biggest secrets to aging for every single one of us. And this isn't just a small step forward. It's a completely new way of thinking about how our cells grow old. I mean, it's the big question, right? The one that drives so much of science and, let's be honest, our own curiosity. What if we could actually reverse aging? It might sound like something out of a sci-fi movie, but a new study is showing us some possibilities that are, well, pretty incredible. So to really understand this breakthrough, we first have to talk about the human story at the heart of it all. A story about a desperate race against a terrifyingly fast clock. This is Hutchinson-Gilford Progeria Syndrome, or HGPS. It's a tragic condition that causes children to age at an incredibly rapid rate. For scientists, HGPS is like a unique window into our own biology. It's a model for understanding the mechanics of normal aging, just compressed into a heartbreakingly short amount of time. And just to give you an idea of the challenge here, HGPS is extremely rare. We're talking about 1 in 18 million people. That makes studying it, and especially finding patients for clinical trials, an enormous hurdle. So how do we fight a disease like this? Well, let's take a look at the current first line of defense, the treatment that has been the gold standard for years. The main villain in HGPS is this toxic, faulty protein called progerin. So the traditional approach has been a direct assault. You find a way to stop this protein from building up and wrecking the cell's command center, the nuclear envelope. The strategy has always been to go right after progerin, head on. Okay, so how does this treatment actually work? Let's walk through it. First, the cell makes that faulty progerin protein. Then, a bunch of enzymes come in and modify it, which is what makes it so toxic. The current treatment uses a drug called lonafarnib that acts like a roadblock. It jumps in and interrupts the process before progerin can do all its damage. The whole goal is just to lessen its toxic effects. And you know what? This approach has been a real success. For kids treated with lonafarnib, studies have shown a remarkable 33% increase in survival, not to mention other health improvements. It's been a huge step forward. But it's not the end of the story. All right, now we get to the new discovery. And this isn't just a tweak to the old strategy. We're talking about a completely different playbook. The new key player is a totally different protein called NAT10. Researchers found that when they used a compound called Remodelin to block NAT10, the health of the cells improved a lot. And here is the absolute game changer. It works through a pathway that has nothing to do with progerin. This is so important, it's worth repeating. The old way was a direct attack on progerin. This new way doesn't touch progerin at all. So instead of fighting the main bad guy, it works on a completely different front, basically reinforcing the cell's own defenses and making it stronger from the inside out. So what happened when scientists actually tested this new idea? Well, the results were incredible, showing real, tangible signs that the aging process was being reversed. This comparison really lays it all out. On the left, you've got the current treatment targeting progerin, but the new approach on the right with Remodelin does something completely different. It was found to decrease markers of genome instability. Think of that like fixing typos and glitches in your DNA's instruction manual. That instability is one of the absolute fundamental signs of aging. And when they tried this in mice with HGPS, the effects were just wow. They were system-wide. We're talking about better heart function, increased fitness, less of that age-related weight loss, and even healing in crucial organs like the heart and its arteries. This wasn't just some minor improvement. It was a massive boost to their overall health. And here is the bottom line: survival. This chart says it all. The mice treated with the version of Remodelin saw a 30% increase in survival compared to the control group. That is a powerful, life-extending effect, right on par with the existing drug, but remember, it was achieved through that totally new mechanism. Okay, so this is where the story gets really, really exciting. Because what does a discovery in such a rare disease actually mean for the rest of us and the future of how we all age? This is where your mind just starts to race with the possibilities. Since the old drug and the new one work in completely separate ways, they don't get in each other's way. This opens the door for a potential combination therapy. Imagine attacking the disease from 2 different angles at the same time. The benefits could be even greater, adding up to something really powerful for patients. But of course, this is science, and we have to be realistic. The researchers themselves point out that we're still in the very early days of understanding this new protein, NAT10. So while the results are so exciting, any potential human trials have to be approached with a great deal of caution. And this brings us right back to the big picture. You see, those hallmarks of aging and HGPS, that damage to our DNA, that genome instability, that stuff happens in all of us too. It just happens in super slow motion over a lifetime. This suggests that targeting this new NET10 pathway might not just be a treatment for a rare disease. It could one day open up new therapies for age-related conditions that affect everyone. So it leaves us with this final amazing thought. Could finding a cure for one of the world's rarest diseases actually unlock the secrets to healthier aging for all of us? It's just a powerful reminder that sometimes the biggest answers are found in the most unexpected places.